Chlorine. Chlorine is necessary in pools to kill bacteria, algae, and waterborne disease. Pools equipped with ozone or UV sanitizers require significantly less chlorine. And chlorine can be manufactured by chlorine generators or dispensed through chlorine feeders. High chlorine demand occurs when you're adding a lot of chlorine to the pool but can't maintain a stable free chlorine level. Something's using it up. Every time you test, the reading will be 0. And we'll also talk about the many different types of chlorine and chlorine shocks, all with pros and cons to their use. There are many different types of chlorine. Trichlor, slow dissolving or fast dissolving tablets are available in either 1-inch or 3-inch sizes. Always use slow dissolving tablets. These tablets are put into the chlorine feeder or chlorine floater. Don't put tablets in the skimmer, it will damage your equipment. Shock is available for superchlorination. There are 3 different types of chlorine shock. Always check the available chlorine percentage at the bottom of the shock container. Powdered chlorine is also available. It is usually higher available chlorine content and must be mixed before adding to the pool. And chlorine can also be generated from a salt system. Sodium chloride undergoes electrolysis to form hypochlorous gas, which sanitizes the pool. Types of chlorine shock. Calcium hypochlorite is inexpensive. However, it adds calcium to the pool water, and you can't remove calcium from the pool water unless you drain a partial amount of water and refill with a lower calcium water source. It also clouds the water, perhaps for even a couple of days. You must premix it, and it can cake up on the inside of containers, making it difficult to mix or combine. Sodium dichlor is a nice mid-range cost shock that won't cloud the water, but it adds cyanuric acid or stabilizer to the water. So if you already have high stabilizer levels, you might not want to choose sodium dichlor. Lithium hypochlorite is a good shock. It can be broadcast over the water without premixing it in a bucket. It's a great problem solver and works well on algae, won't cloud the water, but it doesn't even contribute to calcium or stabilizer levels. However, it can be expensive and it's not available in larger containers. Many people with a high chlorine demand use large amounts of chlorine and still have a 0 free chlorine reading. A stable residual of free chlorine level is necessary to maintain a clear and clean pool. Chlorine demand is the consistent inability to maintain a free chlorine residual in the pool. It's caused by a buildup of contaminants, and it creates an overload on the sanitizing system. It means that more sanitizer is being required than you're providing in the water. If the pool has enough stabilizer, is properly balanced, and you are still using an exorbitant amount of chlorine, and possibly even experiencing an algae bloom, here are some potential causes. You may have nitrates, high ammonia levels, dirty swimmers, washing dirty decks into the pool, blowing grass clippings into the pool, fertilizers, accumulations of leaves and debris, pools left idle or unattended, fireworks, spilled drinks or food in the pool, freshly opened pools in the spring, high bacteria content in the pool, adding household cleaners not intended for pool use, heavy bather loads after parties, rainwater and snow, pesticides, animals and birds in the pool, very resistant algae or construction in the area, and even urine and sweat in the water can cause high chlorine demand. If you do some research, you'll find conflicting information regarding Chlorine Lock. Many don't believe in this phenomenon and attribute the aggravating problem as just high chlorine demand. Others believe that excessively high cyanuric acid or stabilizer levels can cause chlorine to become completely ineffective, thus locking up any free available chlorine and its ability to kill bacteria or algae. Not everyone with high stabilizer levels experiences chlorine lock, though. Thus, it is a phenomenon, a theory, not necessarily a rule. If you aren't experiencing any problems maintaining free chlorine levels and the pool is clear and clean, you don't need to do anything with high stabilizer or cyanuric acid levels. If you do begin to develop algae blooms and can't keep chlorine in the pool, then you might discuss a partial drain and refill with your Blue Haven service team. Chlorine feeders or automatic chlorinators are units that you can fill up with tablets which will dissolve at a predetermined rate throughout the week. Fill chlorinators weekly or more regularly if needed. Shoot for scheduled refills, fill them at the same time every week, and the same dissolve rate that provides a continuous stable chlorine level. Remember, passing water over 9 tabs delivers much more chlorine than the same rate of water passing over 2 tablets. Fill the chlorinator up with water to the brim before screwing down the cap. Otherwise, an airlock or air pocket can form and be trapped inside the top portion of the chlorinator. That will cause 0 or low chlorine levels. Use 3-inch tabs or even 1-inch tabs if you have a high chlorine demand. 1-inch tabs provide a larger surface area and will provide a higher chlorine level. Do not add tablets to the skimmer or to pump baskets. The high chlorine concentrations will cause damage to pool equipment. Some salt pool considerations. Saltwater pools are often misinterpreted as chlorine-free. However, the chlorine generator converts salt to chlorine. Ancillary products such as stabilizer, pH balancers, and algicizers are still needed. The pH of the produced hypochlorous acid is very, very high, requiring more frequent additions of muriatic acid to salt-generated pools. Chlorine generators do not operate at temperatures below 55 degrees. You will need to supplement chlorine in the wintertime. Salt levels need to be topped up periodically, and shocking may still be required to rid the pool of chloramines. Use salt that is specifically designed for swimming pools, at least 99% pure. When adjusting salt, use a chart to determine how much salt to add. Don't just eyeball it. There's no way to remove excess salt from the pool unless you perform a partial drain and refill. And when adjusting, shoot for 3,200 parts per million. Do not use rock or iodized salt. Any kind of salt that is comprised of more than 1% additives can cause heavy staining to the pool surface. Anything that has anti-caking agents, yellow prussiate of soda, or sodium ferrocyanide in it can cause staining. When adding salt, never add salt directly to the skimmer. It can damage the equipment. While the pump is running, add salt around the perimeter of the pool and brush it around until it's fully dissolved. Below you'll find a chart on salt additions. Find your current salt level over on the left and line it up with the amount of gallons of water you have in the pool, and that'll tell you the additional pounds of salt that you need to reach 3,200 parts per million. On new plastered pools, be sure the plaster has cured for at least 30 days prior to adding any salt to the pool. Adding salt before the plaster has cured can cause permanent damage to the plaster. If you found this video useful, please like our video and share it with your friends. Also, please watch our other educational videos on water chemistry to learn more about swimming pool chemistry. And visit and follow our Facebook page for insights, tips, and helpful information about your swimming pool. Thanks for listening.